My name is Courtney Birckbichler. I'm a pre-service teacher at Shippensburg University, where I am a junior majoring in early childhood education, grades pre-K to 4, and minoring in reading. Today I'm here to talk to you about STEAM makerspace stations. Now you might be asking yourself, what is STEAM? What does it stand for? You might also be asking, well, what's a makerspace station? Well, I am here to explain what both of them are, as well as show you my own example of a STEAM makerspace station. So STEAM, what does it stand for? STEAM stands for Science, Technology, Engineering, Arts, and Mathematics. Makerspace station, what is it? A makerspace station is a hands-on collaborative station that children can do in schools or at home that uses your STEAM skills and knowledge. Makerspace stations also enhance student learning by using real-life problem-solving situations and scenarios. Today, I would like to share with you my own STEAM makerspace challenge. I will show you the materials, which are all common household materials, as well as common classroom materials, and I will show you a student example of my STEAM makerspace project. So first, one important aspect of a makerspace project is that all of the materials are either recycled or can be easily found in a classroom or in someone's home. So those are all of the materials that I have used for this project. For this makerspace station, it is called a rubber band powered car. Students will have the freedom to create a car that is propelled by a rubber band, and they will have to use the aspects of math and science as part of their STEAM to measure the distance it has traveled and to use their science skills of physics and energy and motion to propel the car. So the students will be working in pairs or small groups to create their rubber band powered car. Once they've created their first model, they will go through their worksheet and answer some predictions questions about if they think their first car will travel the farthest, or after they have made some modifications, which car will travel the farthest. So after they create their first car and send it out on its first test drive, they will measure the distance that it has traveled in inches. Then they will come back together and make some kind of modification. They can add something or take something away and measure the distance it has traveled with that modification and mark that down on their paper. Last, they will make one last modification by adding something or taking something away, marking down on their paper what they have changed, and measuring the distance that one has traveled in inches as well. And then they will compare the 3 different tests and see which one has actually traveled the farthest and why they think that it has traveled the farthest based on whatever modifications they have made to their car. So now I will show you the materials that have been used for this student sample, as well as the materials that are very common in most households, as well as many classrooms. And I will talk about some modifications that can be made if a family does not have these items or if a classroom does not have these items. So first, for the wheels, this student sample used CDs or DVDs, whichever one you might have, and make sure they are either old or can get scratched, because they will get scratched. A modification for if you do not have CDs or DVDs, you can use bottle caps and carefully poke a hole in the middle to make the middle of the wheel. And something else you can use are children's toys. Sometimes you might have something round lying around that can become a wheel. A lot of times children's toys make great materials for makerspace stations. So the next material you will need is something that can create an axle of a wheel. So in this case, we used wooden skewers, but you could also use pencils, pens, chopsticks, anything that is long and skinny rod shaped. To go along with the axles, you will need something that the axle goes through. So for our student sample, we used straws, and they will be taped to the base, or however your students come up with their idea. We also used a sponge. That's why this one is already cut and in a fun shape. But sponges can also be used for many makerspace stations because you can cut them up, they can be pulled apart, they can be manipulated into many shapes, which is very helpful for all makerspace stations because you need to use your creativity to accomplish some kind of goal. Another material that we will use is paper clips. So paper clips can be used to decorate their vehicle if they want, but it's also an important aspect of how it's being propelled, which you will see in the student sample. And obviously, since this is a rubber band powered car, we need rubber bands. So for my example, I have many different size rubber bands, but if you do not have this many different size rubber bands, you can use hair ties or even braces rubber bands. Some families might have those. Anything that is stretchy and malleable will work. And last but not least, you'll need the actual base of your car. So for this student sample, I used a cardboard box and just cut it, as you can see. And a modification that you can use if you don't have a cardboard box is a cereal box, or even a paper towel roll can work great. So now I'm going to show you the student sample and how. So here is the student sample that was created. As you can see, all the materials plus a little bit of tape to hold things together was used. Straws under there, wooden skewers, CDs, the sponges, the blue part inside there. And to make this actually propel itself, you just wind up the front axle. When you put it on the ground and let go, it'll move. And you might need some adjusting with the wheels, but the students get to use their creativity to create their car and modify it however they think it will travel the farthest. So thank you so much for listening to me and my presentation about my STEAM Makerspace station.